Physical properties of ionic substances. So we remind ourselves that ionic substances are formed from the reaction of metals with non-metals. For example, sodium chloride is an ionic substance. Magnesium oxide is an ionic substance. And these crystals have a regular arrangement of positive and negative charge, so we can look at that in 3D and draw a bonding model diagram. Here's our diagram. So we have alternating positive and negative charge. In the 3D lattice. So all ionic compounds have a high melting and boiling point, and you need to be able to explain the reason behind that. And this reason is that there are strong electrostatic forces of attraction between the positive and negative ions. This is multiplied many times across the 3D lattice structure. It takes a lot of energy to overcome these forces. So therefore a lot of heat is required, which means a high temperature is required for melting and boiling. Crystallinity. All ionic compounds are crystalline. This is because you have got a regular arrangement of alternating positive and negative ions. Electrical conductivity is slightly more complicated. They do not conduct electricity when solid. They do conduct electricity when they are molten, so melted. And also if they're in solution. Okay, so the reasons for behind this: in a solid, the ions are in fixed positions and unable to move. When the ionic compound is molten or in solution, you need to say that the ions are charged particles. They are able to move. To electrodes so that they can complete the circuit and carry the current. A better way of writing that is to complete the circuit and allow current to flow. Solubility. There is a range of solubility in ionic compounds, but in general, ionic compounds are soluble in water. The reason behind this is that water as a molecule is H2O, and it actually has some small charges on itself. So here is a water molecule with its bonds, and what it has is a small negative charge, which we use the Greek symbol delta, delta negative, and then it has a delta positive. So on a water molecule there are tiny charges so the positive and negative ions are attracted to these tiny charges, we call them partial charges, of the water molecules. So hence they can be dissolved into the water.